In a space station far from Earth, how do astronauts survive long term in space? Under normal circumstances, the International Space Station can accommodate 6 astronauts. Each astronaut consumes 18,000 liters of air per day. Such a massive consumption, it is impossible to transport supplies in large quantities from Earth, so the space station, oxygen generation equipment with a volume only the size of a bucket is installed. Relying on electrolysis of water technology, decomposing water into hydrogen and oxygen, achieving in situ production of oxygen for breathing. On Earth bubbles naturally float upwards, but space is in a microgravity environment. There is no distinction between up and down. Gas and liquid cannot naturally stratify and separate. To successfully purify oxygen, centrifuges must be relied upon for forced separation. Space resources are extremely precious. The water resource recycling on the space station is maximized. Not a single drop of water is wasted. Water vapor exhaled by astronauts. Sweat accumulated water body moisture condensation in the cabin. Urine and even daily generated, are all collected and processed uniformly. Through multi-stage precision filtration, distillation, purification and other processes, over 90% of water resources can be recycled and reused. Because the space station is in a microgravity environment, there is no distinction between floor and ceiling. Reading upside down or eating with your head tilted back is common. Each astronaut has a private cabin, equipped with a sleeping bag fixed to the wall. When sleeping, one must be securely fastened inside the cabin, otherwise one will float freely while asleep. Even eating in space has strict requirements. No food should produce crumbs or water droplets. Once scattered, they can usually enter precision ventilation equipment and cause malfunctions. Precisely because of this, corn tortillas, which do not easily crumble, have directly replaced bread as the main staple food in space. Long-term exposure to a zero-gravity environment causes human muscles and bones to rapidly degenerate and shrink. Therefore, astronauts must spend 2 hours every day using specialized fitness equipment, simulating Earth's gravity movements with elasticity as resistance, to maintain the stability of various bodily functions. The remaining time is mainly used for scientific experiments and space station maintenance. The microgravity environment of the space station is a natural top-tier laboratory that cannot be replicated on Earth. Researchers focus on observing the comprehensive effects of weightlessness on the human body, monitoring bone loss and muscle degeneration, changes in vision and cardiovascular responses. The precious data collected are important references for future Mars missions. In addition, special physical phenomena under zero gravity can be observed. Without the constraints of up and down gravity, spherical droplets are formed by floating. Water droplets condense into perfect spheres formed by floating spherical droplets. The shape of flame combustion, the way heat propagates, is also completely different from Earth. Space biology experiments have also yielded fruitful results. Astronauts cultivate space plants under microgravity, exploring self-sufficient cultivation methods on alien planets, observing microorganisms, the mutation patterns of cells in extreme space environments, contributing to the development of new Teixeira drugs. The entire space station's daily operation relies entirely on solar power. Its solar panels, the size of a tennis court, can output up to 120 kilowatts of electricity. Compared to power generation, the most challenging problem is actually the extreme temperature difference. When the space station directly faces the sun, the cabin surface temperature can reach up to 121 degrees Celsius. Within a few minutes it enters Earth's shadow. The temperature instantly plummets to minus 150 degrees Celsius. Every 90 minutes it experiences a cycle of extreme heat and cold. To maintain a suitable temperature inside the cabin, the space station is equipped with a professional temperature control system far exceeding that of a car's radiator, using internal pipelines to collect excess heat through a liquid ammonia medium that is resistant to high and low temperatures. Transfer heat to external giant heat dissipation devices for radiation. Maintain a suitable cabin temperature day and night. In addition, space orbits also harbor significant safety hazards. Hundreds of thousands of space debris of varying sizes roam around. They travel at speeds of up to 8 kilometers per second. Even a tiny grain of sand can easily penetrate the space station's hull. To this end, the space station is specially